Hey guys, in this video I'm going to show you how I used a Nextion touchscreen along with an Arduino to control an attic fan to help keep my attic cooler and lower my air conditioning bill. In this video I will go step by step through the software, first with the Nextion touchscreen display and then through the Arduino. If you haven't seen part 1 of this tutorial, you may want to go back and watch that video first. In that video I cover the installation and wiring of the attic fan. Let's start with the Nextion Editor, which you can download for free from Nextion's website. When you start a new project, it will ask you to give your project a name, then it will ask you to pick out which Nextion touchscreen you chose for your project. I used a basic touchscreen. I used the 2.8 inch 240 by 320 pixels. Once you select that, it will ask you to choose your orientation. This depends if you want it portrait or landscape, and depending on which side you want the cables to stick out. Rather than start a new project, I'm just going to open up the attic fan project, which will save us a little bit of time. The first thing I'm going to show you is this box over here on the left. First we're going to click on our pictures, and these are the pictures that I used in my project, and you'll notice that the pixel size is the exact same as the Nextion touchscreen. So you need to make sure that you crop the pictures to the right size before you import them. Another thing you need to do before you get going too far in your project is add different fonts. And as you can see, I have several fonts I've used here, and the way to create a new font is to go to Tools, Font Generator, and you can select whatever font you want. You can change the size and then you save it, and once you do, it gets added down here. Alright, the next thing to talk about is this page manager over here on the right. To add a new page, you simply hit the plus button, and you can rearrange the order of the pages by using these buttons here. You can rename the pages. We'll just call this dummy. And if we go down here, you can see some of the properties associated with that page. We have the width and height, and we have the X and Y centering location, and you can see that the background is solid color. We can also choose an image, and we can choose between our pictures if we wanted to use one of these, or we could change it to a solid background color and go in and change colors. We can also pick custom colors. This first page here is for when the Nextion is waiting to hear communication from the Arduino. We have our summer mode, which is the mode that puts our fan into automatic mode. We have a settings page where we can adjust the dead band and delta T, the delta temperature, or basically the temperature difference at which we want the attic fan to turn on. We have our winter mode, which disables the fan, and then our information page. So this explains the delta T and the dead band pretty well. If we have a delta T of 10 and a dead band of 2, the fan will turn on when the attic is 10 degrees warmer than the outside, and will turn off when the attic is 8 degrees warmer than the outside. So let's just walk through one of the pages here. As you can see on this main page where the fan will be in automatic mode, I've got 4 different text boxes and 2 different buttons. Let me just click on one of the text boxes here, and you can see the properties for that. Has a ID number of 3, object name of T1, and I've used this crop image, which basically makes the gauge transparent. We could make it a solid color, or we could select one of our images, or if we wanted to make a custom image for this, we could. But I use this crop image so that no matter what the text is, we can see the image behind it. You'll also see that I used font number 2, which is our Arial Bold 40. So we got the big heavy letters, kind of like this text box here. And I've got it center justified, both in the X and Y direction. Over here we can change the text color, and we can change the default text. Now that will appear up here.
This is the maximum number of characters that we want the text box to contain. And then you can also see the X and Y position of the upper left corner of the text box and the width and height that we can change. Now you'll notice that some of these properties are shown in black and some are shown in green. The ones shown in green are the ones that we are able to change dynamically through the serial port. So we can, for example, change the text for this text box using a command coming from the Arduino. When I get into the Arduino code, you'll see that I'm using this text 0 for the attic temperature. Text 1 will be the outside air temperature, text 3 will be the temperature inside the house, and text 2 will be the display for whether or not the fan is on or off. Now the background screen as well as these text blocks can kind of be used as buttons as well. You'll notice down here that there's a touch press event and a touch release event, and you can have the Nextion do different things when these parts of the screen are touched. And in this case, no matter which text blocks I am on, I'm going to print the word wake and send that through the serial port to the Arduino, and in return the Arduino will send back a command to the Nextion to wake up from sleep mode. Now buttons are very much similar to the text boxes. They have similar attributes, and you can change the font, you can change the picture or make it a solid color, change the width and height and the location on the screen. But most important are these touch press events and touch release events. So for this button here, it's going to switch from summer mode to winter mode. And for button 0 here, it is going to send a command to the Arduino to enter the settings menu. Nextion has a built-in debugger which will allow you to test things out before actually installing your software onto the Nextion device. On Nextion's website, there's an instruction set which lists all of the different serial commands that you can send from the Arduino to the Nextion. After each command from the Arduino, we will be printing this string right here, which will tell the Nextion that the command has finished. Back here in the simulator, we can simulate these commands coming from the Arduino. So if we wanted to change the page to the summer page, we could type in page summer. If we wanted to go to the settings page, we could type in that command and go to our settings page. Now I will be using the Arduino to change the text values that appear in the text boxes. And if we want to simulate that, we can simply type in the ID number of the text box that we're interested in, and the software will pull up a list of possible commands that we can use. In this case, we're going to use T0 text equals hello world, just for an example. And here we have it up here on our screen. So over here we type in the commands that we're sending from the Arduino to the Nextion to see how the Nextion will respond. And over here in this simulator return box, we get the commands from the Nextion to the Arduino. So if I click a button, for example, we'll see this hex command being sent. But if we switch it to a string, we can see the command being sent to the Arduino is a delta minus. Here we have delta plus, deadband minus, deadband plus, summer mode, and the info. Now all of these commands will make a little bit more sense when we look at the Arduino code, which really will control this attic fan. So let's pull that up and take a peek. The first thing I did in the Arduino code was pick a pin that would be used to control the fan, and in this case I picked pin number 13, and the reason why I did that is because there is a onboard LED that's tied to that pin, so I could test out the software without having to actually connect the fan. Next I used some unsigned longs to keep track of the timing of the software. This first one, start time, is used to determine how long since the screen last had a refresh. This 2-second interval here will update all of the temperature gauges. This disable time will be used to determine when the Nextion was last told to wake up from sleep, and this disable interval will put the Nextion to sleep after 2 minutes without a button push.
I'm initializing the software with a 2-degree deadband, which will prevent the fan from toggling on and off too many times, and a delta of 10 degrees. This will be used to determine what time the fan comes on. It's based on how much warmer the attic is compared to the outside air. Next, we have an integer to keep track of which mode we're in. We have a blank string command that will be filled with commands from the Nextion, and we have 3 floats, one to calculate the attic temperature, one for the outside air temperature, and one for the difference between the two. These 2 libraries will be used for the DS18B20 temperature sensors. I am using 3 of those sensors, and they are all going to be connected. The data wires on those 3 sensors will be connected to Arduino pin 7 using the one-wire protocol. Now, because I'm only using one data wire for all 3 sensors, I need the Arduino to differentiate between the 3 different temperature sensors. I used a different subroutine to find the addresses for each of the 3 sensors. This first one will be for the attic temperature, the second one for the outside temperature, and the third one for an inside temperature probe, which I'm going to put inside my wall. The first thing I'm doing here in the setup loop is establishing communication between the Arduino and the Nextion. So I'm starting the serial port and I wait 3 seconds, and this is so that when I power up the system, the Nextion has about 3-second head start to boot up before we start sending commands from the Arduino. The first command from the Arduino will be set the page to the winter page, which by default has the fan disabled, and to set the brightness to full brightness. Next, we establish communication with all 3 temperature sensors, and we initialize our start and disable times. We also set our fan pin to an output mode and write low to that pin so that we make sure that the fan is turned off when we first start up the system. The first thing we do inside the loop is to check if a command has been sent from the Nextion to the Arduino. So anytime that there's any command received, we turn the brightness of the Nextion up to full brightness, and we turn sleep mode off. We also reset the disable time, and we read that command into this command variable. Now, depending on what the command is, we will have the Arduino do different things. So if the command is the word winter, we will set our Nextion page to the winter page and set our mode on the Arduino to mode 2 for winter. If the command is info, we will go to the info page on the Nextion screen and set our mode to 3. Now, if we receive the word settings from the Nextion, we'll of course go to the settings page on the Nextion, and we're going to fill in T0 and T1, which are the 2 text boxes on the Nextion screen. We're going to fill them in with the string that the delta T is equal to whatever value is stored on the Arduino for delta. And then of course we'll have our terminator commands here. We'll also update the deadband is equal to the deadband value stored on the Arduino and terminate that line as well. And we will set the mode on the Arduino to mode 1. If we receive the string summer from the Nextion, we will of course go to our summer page on the Nextion. We will set our Arduino mode to 0, and we will request all 3 temperature values from our 3 temperature sensors. We'll compare the attic temperature to the outside temperature to determine if our fan will be on or our fan will be off. On the settings page of the Nextion, there were 4 buttons that were used to increase or decrease the delta T value or the deadband value, and depending on which button is pushed, different words will be sent to the Arduino. In this case, the word delta minus is sent. We will decrement that value by 1, but we want to keep it to a reasonable range, so we're going to constrain those values to stay between 8 and 20. Of course, we're going to update the screen to display our updated value, and we do the same for the other buttons. I mentioned earlier that the Nextion would refresh the temperature gauges every 2 seconds, and this is the command that checks if 2 seconds has elapsed. And if so, we will request all 3 temperature values, and anytime the mode is equal to summer or winter, we will update those 3 temperature values on the Nextion display.
Because the values from our temperature sensors get sent to the Arduino as text, we need to convert them into numbers so that we can compare the two temperatures. And here we're calculating our delta T by comparing the attic temperature to the outside temperature. Now if we are in our summer mode and our calculated difference between the attic and the outside exceeds our limit, then we'll turn the fan on to start cooling off the attic. And we'll leave that fan on until the temperature drops to the set point minus the deadband temperature. Now if we're in the summer mode, we want to update the Nextion to display whether or not the fan is on or off. But when we're in the other modes, such as the settings mode, we still want the Arduino to determine when to turn the fan off and on. We just don't need to update the display. Now, regardless of the temperature difference, if we're in winter mode, we want that fan disabled. And finally, if the Arduino doesn't receive a command from the Nextion in a 2-minute interval, the Arduino will send a command to the Nextion to put it into low power mode. I've been using this fan for a few weeks now, and it is pretty apparent that it is keeping the attic cooler than normal, and I suspect that it is reducing the amount of time that my air conditioner is running and hopefully saving me some money. Well, I really hope you've enjoyed this 2-part tutorial on how I installed an attic fan using Nextion control coupled with Arduino. Please leave any comments or questions in the comments below, and as always, thanks for watching.